Finding all the values t on the interval 2 to 4 where the speed of a particle is 2. Remember that speed is the absolute value of velocity. We have a calculator to use for this problem, so we want to set the absolute value of velocity equal to 2. By setting the absolute value of velocity equal to 2, we can pick up our calculator to solve this by moving everything to one side equal to 0 and see where it's crossing the x-axis, or we can write an equation with what's on the left side of the equal sign and write a second equation with what's on the right side of the equal sign. That's what I decided to do here. So make sure you know how to graph the absolute value in your calculator. If you're on the Inspire, it's going to be where all of your fractions and all of those other fun options are. If you're on the 8384, if you do catalog, the very first one sitting there is ABS, and that's your absolute value. If I graph it with two separate equations, the intersection of these two is where this is going to happen. So at 3.1276 and at 3.473. So those are our times. We get 1 point for considering the absolute value of velocity equal to 2, and 1 point for the answers 3.128 and 3.473. Again, if you wanted to, you could subtract the 2 over and enter all of it in for one equation and see where it crosses the x-axis instead, and it'll still cross at 3.128 and 3.473. Write an expression involving an integral that's going to give us the position at any time t, s of t, and use the expression then to find the position of the particle at time 5. So we are not going to worry about that second part yet. Use the expression to find the position at time 5. Normally we jump right to that and we'd have the integral from the time that we know the position to the time we want the position. In other words, in this case, we know the position at time 0, so I'd set up the integral from 0 to 5. But because we want to have an equation for s of t, I'm not going to immediately put in time 5. I'm just going to say from 0 to some generic time t. If we get s of t alone, we can add over the position at time 0. And that was given. The position at time 0 was 10. So s of t equals the integral from 0 to t of the velocity function dt plus 10. Now I'm going to go ahead and substitute in the 5. And then we can grab our calculator and find this integral from 0 to 5. And then add 10. We get negative 9.207, which means the position of the particle at time 5 is negative 9.207. Part B was worth 2 points. 1 point was given for the s of t equation. S of t equals the integral from 0 to t of the velocity function dt plus 10. And 1 point was awarded for the answer negative 9.207. In part C, we want to know when the particle changes direction. Remember that you can't change direction unless you first stop. So the potential places where we might change direction is where the velocity is equal to 0. All right, so we're going to set the velocity equal to 0 to figure out the potential places where we might change direction. To solve this equation, we can graph the left side and see where it crosses the x-axis. When I graph it, I find the x-intercepts are at 0.536 and 3.317756. Both of these are contenders because they're on the interval 0 to 5. So I put them on a number line. remember that a sign chart is invisible to the AP reader, but it's still a good idea to make the sign chart just to help you organize your thoughts. I substituted values around 0.536 and 3.317756, substituted time zero into the velocity and got a negative answer, which means at time zero the particle was moving backwards. Substituting 1 into the velocity, I got a positive, which means the particle was moving forward at time 1. And substituted 4 into the velocity and got a negative, which means the particle is moving backwards at time 4. So that means at both time 0.536 and time 3.318, the particle was changing direction. We want to make sure we don't say that the particle was changing direction because it changed signs. You need to be specific. The velocity function changed signs. You don't have to be so specific that you say that the velocity changed from negative to positive or positive to negative at those times, because any change of sign in the velocity would be a change in direction. Okay, the points awarded, we had 1 point for setting the velocity equal to 0. We got another point for getting times 0.536 and 3.318, and a third point for the justification, which was V of t change sign at these t's, or at these times. So for part D, if we want to find out if something is speeding up, we want to compare the sign of the answers to velocity and acceleration. The velocity of the particle at time 4 is negative 11.475758. To find acceleration, that is the derivative of velocity, and your calculator will find the derivative of a function at a value. So the acceleration at time 4 is negative 22.2957. Since the sign of both velocity and acceleration are both negative, then the particle is speeding up. There was 1 point for finding V of 4 and A of 4. A of 4 and V prime of 4 are the same thing, so either of those is fine. And 1 point for the justification that the velocity and acceleration at time 4 are the same sign.